Hello and welcome. In this presentation we're going to be discussing IEEE 802.15.6 Standard Human Body Communications Physical Layer Specification. Introduction. IEEE 802 has established a task group called IEEE 802.15.6 with the purpose of establishing a communication standard optimized for low-power in-body/on-body nodes to serve a variety of medical and non-medical applications. In other words, for the standardization of the wireless body area networks. IEEE 802.15.6 supports three operational physical layers. A physical layer is responsible for activation and deactivation of the radio transceiver, clear channel assessment, and data reception and transmission. The three physical layers supported by the current IEEE 802.15.6 standard are narrowband, ultra-wideband, human body communications. Human body communications is what we're going to be focused on in this presentation. And in the image below, we can see the operational frequency ranges of each physical layer. And as you can see, human body communications operates within the frequency range of 5 to 50 MHz. Human body communication physical layer operates in a frequency band centered at 21 MHz. The data rate is up to 2 megabits per second, range is up to 3 meters, power consumption is very low, and circuit complexity is very simple, and modulation type frequency selective digital transmission. Human body communications packet structure. The HBC packet is composed of PLCP preamble, start frame delimiter, PLCP header, and physical layer payload, or PSDU, or physical layer service data unit, as shown in the image below. The physical layer payload is composed of MAC header, MAC frame body, and frame check sequence. Modulation. The HBC transmitter uses the Frequency Selective Digital Transmission, or FSDT scheme. Data to be transmitted through the human body is spread over the selected frequency domain using a group of digital codes without a continuous frequency modulation. Hence, the HBC has lower circuit complexity and low power consumption. Some of the latest SFDT methods use Walsh codes. Walsh codes are mutually orthogonal error-correcting codes. By using a group of Walsh codes, 16 codes out of the 64 Walsh codes that have the highest fundamental frequencies, the information is spread into a selected frequency. The spread spectrum has the advantage of guaranteeing the quality of communication. Chip errors up to 31 do not cause bit error. Earlier system makes use of Manchester coding. HBC transmitter. The HBC transmitter may be composed of the following reference blocks: preamble generator, SFTRI generator, header generator, serial to parallel block, frequency selective spreader, pilot generator, and a multiplexer. The generated preamble, SFTRI, header, PSDU, and pilot signals are sent to an electrode via a multiplexer. In this image, we can see the block diagram of the HBC transmitter. PLCP preamble. Physical layer convergence protocol preamble contains the packet of synchronization and channel estimation sequences. A preamble sequence is transmitted 4 times to achieve packet synchronization by the receiver. During the transmission of the code preambles, the pulse repetition frequency of a clock pulse generator is adjusted at the receiving end. Start frame delimiter and rate indicator. The SFTRI field is used as start frame delimiter for non-burst packet or used as a rate indicator for burst packet. During packet reception, the receiver finds the start of the packet by detecting preamble sequence, and then it finds the starting point of the frame by detecting SFT. Unlike preamble sequence, SFT sequence is sent only once. When it is used for RI mode, The SFTRI field indicates the transmitted packet data rate. At RI mode, the receiver does not need to refer to the physical layer header to detect the incoming packet's data rate. This allows the header along with the payload be transmitted at the same high data rate, increasing transmission efficiency. PLCP header contains the following: data rate, which is the data rate of the PSDU, the pilot info, which is the pilot symbol insertion interval, burst mode, scrambler seed, physical layer service data unit length, PSDU length, and the cyclic redundancy check value of the PLCP header. A scrambler is a device that transposes or inverts a signal or otherwise encodes a message at the sender's side to make the message unintelligible at a receiver not equipped with an appropriately set descrambling device. These are little side notes. A cyclic redundancy check is an error detecting code commonly used in digital networks and storage devices to detect accidental changes to raw data. A pilot signal is a signal, usually a single frequency, it's for radio communication, transmitted over a communications system for supervisory, control, equalization, continuity, synchronization, or reference purposes. PSDU contains the following: MAC header, MAC frame body, and frame check sequence. Transceiver specifications. A transmit spectral mask is used to remove harmonics and possible interference in other bands, especially with 400 MHz medical band. Image on the right shows the required transmit spectral mask for channel with 21 MHz sender frequency and 5.25 MHz bandwidths. The electric field strength produced by an HPC electrode radiating in free space measured at 30 meters shall be in compliance with local regulations and under any circumstance shall not exceed 30 microvolts per meter. The symbol clock frequency tolerance shall be plus minus 20 parts per million maximum. And thank you for listening. Hope you enjoyed it.